Good morning, everybody, and welcome to our first Cloud Native Journey for Partners. Thank you for joining me. I'm very happy to see you, all of you. For those who subscribed, for those who are watching this later on, thank you for tuning in. And I hope I can enjoy you delivering some information on containers on Azure, and I hope you will be enjoyed as well. Please, if you have any questions, put them in the chat window. I will read out the questions out loud, so that way we can all be as flexible as possible when it comes down to asking questions. Feel free to keep your questions till the end, or feel free to ask them during my session. I will try to address them as appropriate. All right. So let's talk a little bit about containers on Azure. This is the first of a series of cloud native development sessions that we're going to do. This is a generic intro on all the technologies that we have inside of Azure, which are related to containers and which you can use on a container basis. So if you probably already are aware for a couple of these technologies, so I'm sorry for that if you already know those. For those who don't know, sit back, enjoy the ride, and let's take this together. Okay. So why do we look at containers? It's very easy. Our lives have changed a lot over the last 20 years when we talk about computer estate and computer capabilities, and applications become more and more complex, and we need an additional way of making it easy for ourselves to switch between either a cloud provider, a on-premise data center, or just running things from a developer's perspective. Right? Today, if we take a look at how landscapes have been built, we typically see that a lot of people are just doing containers as a means of easy deployment and easy movement between different kind of organizations and between different kind of compute ways. Yeah. It's also typically the first step into a modernization trajectory, and typically everybody reaches out to containers as the basis to start running microservices. Now, a little nuance on that. For me, microservices are not based on containers, but containers can be a mean to run a microservice because it contains everything that you know. Some of the benefits that we have, if we take a look at the things that you can see, you can run more material nowadays on in the same machine when running services in containers than you used to do in a traditional VM way. And you can even deploy a lot faster. These are some numbers that we got from a 2017 State of DevOps report, and these numbers are still being proven today in our industry. Some of the benefits that we have of using containers are, for typically the developers, the agility. You ship the app faster. No longer on a Friday evening, ship it. Then build, kicking off the build, and then some IT pro on a Monday morning gets a pain, a headache of seeing an application that he needs to deploy, setting all the settings in an IIS server or an Apache server. So that's kind of the pain that we've gone past. It's way easier to ship an app, and the movement, the portability is the additional part next to that. Also. The benefit of a container when it comes down to resources, you can easily say this container has a high impact on resource performance. I need to add more memory and more CPU to that specific service or that specific application part. You can easily do that, right? And of course, it's the go-to method to start building SaaS applications or a modern way of offering your applications to end users, because it can scale way more easy than just say putting VMs next to each other and adding additional VMs behind load balancers and putting all those things into a nightmarish way of operating. Okay. Some numbers when we talk about, and that's the funny thing, there's always numbers in these slide decks, but it's a given that containers is only the start. We typically talk about containers in a more orchestrated way. Yeah? About 70% of all the companies who use today containers, they also use an orchestrated, and they typically choose for technologies like Kubernetes or something particular like that, or a Kubernetes-based thing. And larger companies are typically leading the adoption. Well, this is not abnormal because they typically have the means and the resources to do so, to invest on new technologies and to see where they should be going. But also, and that's where I saw that in the past, I work a lot with ISVs. Also in the ISV sphere, there's a lot of good reason to use Kubernetes or a container orchestration method to make your solution way more scalable and way more manageable. A little bit on the basics. What is a container? What's the difference between a container and a VM? Well, in a VM, you typically virtualize the hardware, where in a container, you virtualize the OS. And in a virtual machine way of doing things, the VMs are the units of scale, where the in the container way of living, it's the application which scales instead of the VM. So typically, and I get that question a lot from specifically from IT pros. Yeah, but I still don't understand it. I explain containers to IT pros typically as, you can compare it to app V. You bubble your application, you put all the dependencies in there, and then you deploy it like that, and then you kind of stream your applications. Just the same way of addressing it. It's not totally the same as app V, of course, and there's different technologies behind it, but the concept is the same. You bubble your application, you put a streaming around it. Okay. Some of the benefits of using the containers, it can be any OS. Whether it's Linux or Windows, we now have Windows containers also, and there's support for Windows containers. It can be run anywhere, whether you run it on premises or whether you run it in a cloud of any flavor. Containers can be just moved. There's some discussions going on that, Kubernetes is not the holy grail of container movement. That could be a good given, because there's still some specifics per cloud provider, where each cloud provider had some additional benefits or additional features to Kubernetes in their flavor, but the base Kubernetes always stays the same. Yeah, but you still need to then manage all the other specific cloud flavors. Yeah? If you're running Kubernetes, like for instance on VMware, or if you're running Kubernetes in our Azure cloud, there's still some additional things that you can do in the VMware part, which we might not have, and vice versa. So you need to keep that in mind. But the natively built Kubernetes itself will stay the same, and your application will react the same. Yeah, so that's the only thing that you need to keep in mind. And it can be any app, whether it's a monolith. You typically see that in the modernization track, you start off by, if possible, moving a full monolith inside of a container and deploying that one, or a microservice-based version of an application with multiple APIs, or something in between, because you don't have to always move away from a full monolith. You can just gradually migrate away your services out of it, or deploy new services next to it in combination with a container service or a Kubernetes service, and maybe add some serverless to that. It doesn't have to be something which is solely focused either on a monolith or on a microservice. You can easily combine both of them. But the best of all is that a container is like everybody's friend. It's like a dog that you owned when you were a child, and that dog was very friendly to everybody. Containers are just the same. They support any kind of language, any kind of technology that you'd like. They typically can be built up. If you don't find your flavor there, you can still run it in a container, and it will probably work. Maybe with some tweaks and some figures, but we have full support in containers for Java, .NET, of course, with .NET Core. Python is a very nice way of running containers, specifically if we talk about machine learning capabilities and deep neural and networking. This is where containers really come into place, and of course technologies like Node and all these things. Yeah. So this is containers. There's more benefit to it than not running in the container. You have a lower management plane, a smaller management plane, a smaller way of managing all your assets from that perspective. Some other container advantages. What you typically have in a virtualization, in a virtualized environment, is that you run your application in a hypervisor, and they typically have a low utilization of container resources. You can fully move everything over. If your VM is deviating a little bit from the other VM, no issue there. Your container will still react the same. Of course, if you close all the ports on that VM, that's a different story. That's a networking thing, but your application will stay the same. And your agility stays across the entire lifecycle between operations and development stays the same. So you only have one asset that you push through, and you can easily just continue with those. The beauty of it is also that if you have underutilized VMs, for instance, you can easily move away and migrate containers to another environment and start consuming a little bit more. Yeah? And then they can start doing some consolidation and do some decommissioning for unused resources, which give you a cost benefit. Yeah? And as an addition, containers are very lightweight, and they're very much faster to scale dynamically, whether it's either in a native way of using the Docker engine or a container engine, or whether it's in an orchestration. You can easily scale it, and they typically start up in a very quick way and in a very agile way. Okay. Now, when we talk about containers is typically an acronym, an alternative name for Docker. Now, I gotta disappoint you. There's other container technologies, but Docker is the most widely spread and the most widely known. What you typically see is that a Docker file is easy to create. Going from a simple Docker file, in this case, you start from scratch, which you just get a base Docker container. You copy hello inside of the container, and then when you start up the container, you run a command, in this case cmd /hello. Hello is a resource that we built before, right? And then we need to build a container, in this case docker build -t, which gives you the tag for the hello world image, and the dot means that you're going to build specifically the Docker file, which you are in that specific directory on that specific folder. And then, of course, you need to run it. Now, this way of handling the Docker file is typically for all the technologies that are at hand, which are using containers. And you can use a simple Docker script or a simple command line script to build and to run your container, or you can do that in a more professional and in a more organized way by means of CI/CD, with support of CI/CD for, let's say, your Jenkins or your specific task in Jenkins or specific task in Azure DevOps and GitHub or whatever you have. Okay, any questions so far? I see nobody raising questions, which is good. Okay. Of course, if we talk about Docker, we typically talk about orchestration, and the benefits or the elements of orchestration are typically like health monitoring. You have to have high resiliency, which comes together with scheduling, scaling, and service and health monitoring again. We also talk about app upgrade coordination to make it easier to not break a running production environment, but gradually upgrade the environment and make sure that only those services that are not running are being upgraded first, so that way end users won't notice a lot of the upgrades that you're running. So that's part of the entire story. Something that can help with those things is, and I mentioned it already, is something called Kubernetes. Kubernetes is a orchestrator specifically for containers. It's built to be portable. It's built to be extendable and self-healing, and it has all the specifics for a fully, how should I put it, adult and mature orchestration software. The thing is that you can easily have auto healing by means of auto restart and auto replication, auto scaling. We implement the same things inside of the Azure environment, but also from a extensible part, it can be modular, it can be pluggable, and you have things like support for all these mesh networking technologies and all these things that are being built up today inside of Kubernetes. We have multiple flavors of Kubernetes. As I mentioned before, a couple of them are running inside of Azure. We have Red Hat. We have Azure Kubernetes services. But if you want to run your own, perfectly possible. You can go from there if you want to. You can run your own cluster at your own VMs, and if you want to manage it all, go ahead, knock yourself out. We're not going to hold that against you, but do know that there's more benefit of running a managed service than running an unmanaged service. What can we offer containers on Azure? Well, we can offer you a couple of things. First of all, we can offer you flexibility, we can offer you productivity, and we can offer you trust. Trust, this is something for those who have been using Azure the last couple of years. This is something we gain momentum on, and which is something we really heavily invest on. It's not only from a compliance and regulatory aspect, but also from a availability aspect, from a monitoring aspect, and from a security aspect. We put a lot of effort in making Azure a trusted platform on many levels, and we implement a lot of security measures, and we implement a lot of ways of implementing your services in a secure way, the way you want to deliver services back to your customers or your end users. Also, from a flexibility point of view, we have a lot of offerings where you can run containers in, and I'm going to show you that in a second. So do know that you can have a choice, but depending on the situation, of course, you will either choose one or another. Yeah. And then from productivity, well, we have a lot of support for tools that you can use around those things, and again, flexibility there. Now, when we talk about containers in Azure, what can we offer you? We can offer you app services with native support for containers. We can offer you container instances, which are standalone containers, or an elastic burst for your Kubernetes service. We can offer you Service Fabric, which is more to the traditional .NET applications, or even .NET Core applications. And then we have Kubernetes service, which is, of course, based upon either Linux or Windows nowadays, which we also support. And bring your own is also a possibility. On top of that, we are offering support for a couple of registry and image registry or container registry technologies. One of them is, of course, Docker Hub, which is an open platform where you can support any kind of Docker container which is available. But we also have two of our native registries. We have the Azure Container Registry on the one side, and we also have nowadays support for containers in through GitHub, through the GitHub Package Manager. So, which is also a possibility to host your container images. And then from there out, you can start building up with the tools and the clients that you love. Typically, you use a Docker client to still do dev and build, but you can easily use like Visual Studio or GitHub Codespaces or Visual Studio Code or Rider to create your containers and to move forward with your container development. Because typically a container is only a deployment vehicle. It comes with the development part, but typically you first focus on your application, of course. So when do you use what? So if you are without a preferred container platform, what kind of choices do you need to make to go onto which platform? Well, first of all, if it's just simple APIs or web apps, single things, and you want to make sure that it's just an easy scalable way of doing stuff, then app services is the easiest way to get started with containers. App services is a PaaS platform, and you can easily use that to your benefit. Also, if you want to have more scale and orchestration, then app services is not the best way to do, because you have some more complex scenarios. You probably will have more APIs, and you will probably have more front ends that you want to host in separate spaces. Then you typically look at a Kubernetes environment. And last but not least, if you still want to use some older .NET applications, we still offer Azure Service Fabric to use Windows Server containers. We also are almost there with the Azure Kubernetes services for Windows containers, which are also available. But do know that you have a choice there to run it in a more different way with Azure Service Fabric. How can you benefit from the productivity? Well, today our tools are offering a lot of capabilities to immediately containerize and scaffold any application directly from the IDE. So you can just say, and of course you shouldn't be doing it, but you can easily say right-click deploy to containers from Visual Studio, but you know, friends, don't let friends right-click publish, but know that you have this capability. We also have a lot of plugins for Visual Studio Code that support container building, whether it's native Docker or whether it's from a Azure point of view. Yeah. And then you can also use a more automated way of building by means of a secure container registry, which we also support to build inside of the registry. So you build your container, you push it inside of the container registry. That registry will then be your deployment place instead of your binaries. And then you can start moving around between all the different environments, like your dev test, your UAT, and with even just a little bit of a tweaking, you can easily set up a full CI/CD pipeline with even static analysis of your code and secure your code, pushing in like secrets through means of key management systems, and making sure that your container will be deployed and will be built safely. And in the end, we offer you a lot of monitoring tools to look at the application itself, but also at the container health and at the security of your containers and your Kubernetes platform for that matter. So you can use a lot of our services from the marketplace, which you can immediately plug in inside of your and connect to your containers. Of course, everything works nicely together in Azure. Whether it's databases, whether you want to deploy your container on the edge by means of IoT, whether you want to use open source databases from that perspective. We all support these with even bigger integration, like in different services, API management. All these things are there for your benefit and for your use, of course. Managing your container infrastructure. I already mentioned container registries. You can use any kind of Docker CLI to manage it directly. We offer full management support for the CLI from within Cloud Shell, for instance. But more important is that you have a decent monitoring. And there we go. We try to go the extra mile. Either you if you're using Kubernetes, you integrate together with Prometheus inside of the Kubernetes cluster, or you do native application insight and container insights and log analytics. And you can easily integrate your container application with things like Active Directory to secure your applications even more. But also Azure Security Center is coming to play a lot on this level, because from there out we also monitor your container estate, whether the containers are safely built and not containing any vulnerabilities, but also the way your Kubernetes environment has been configured. And then afterwards, even Sentinel can come to play to monitor your attack scope and your surface to see whether there's any issues there and whether there's any lateral move within your containers, for instance. So, app services. We do a lot of work to tightly integrate with any of the registries. It's a simple switch of the app service container that you can just use your container with. So you can just easily say, I want to switch my container in the background from the portal, or you can just use the AZ CLI. We can have built-in CI/CD with deployment slots. So you have a deployment way of hooking into the Kudu backend, and Kudu then will do a git deploy inside of your environment by means of the containers. Yeah. And we also have diagnostics and troubleshooting from that part on the outer loop. It's a fully managed platform. You can auto scale. You can scale on basis of some metrics that you can set up, and we also do auto patching on that level. And the beauty of it all is that it comes with a built-in backup and recovery system starting, of course, from the standard environments. So that way you can easily restore previous versions and so on and so on. We have support for the CLI, we have support from the portal, we have support from an ARM template. We also have support from any kind of IDE, of course, which are using all these three forms. And it can go from a single Docker image up until to multi-container images with Docker Compose. So if you have a multi-container application running, let's say with a front end and a back end, and you want to build those two together and deploy them together, that is also supported with Docker Compose. And of course, the entire development tooling that you have around containers and app services are also supporting this kind of deployment. If we take a look at how that works from within the portal, for instance, I'm just going to quickly go and take a look at our. I have a static website deployed inside of a container. Why? Because it's the quickest and the easiest, and it's just a basic thing. Let me just open this thing up. As you can see, this is just a static node application running inside of a container. Just build it up with Visual Studio. What I did here is here are my containers. This is being hooked up to the a container running from the Azure Container Registry. I can easily just switch that over to a private registry or to Docker Hub. Native support for GitHub will come here Two, you set some of your specifics. You can take a look at your logs immediately, and this is where your container is being streaming the logs into the portal to see where do you have any issues inside of your application, how it is behaving towards the outside. It will just create a standard URL like any other app services URL. So you don't have to do anything specific. The only thing that you need to keep in mind is that you container ports towards the application itself. And then from there out, you can have some deployment slots if you want to, and you can also have the deployment center where you can hook up your environment. And I did this here by means of a build that I did on an Azure DevOps environment. But this can just easily be a container registry build or whatever you have. If we then take a look at the application, it just runs and reacts like any other environment. Some of the things that you can do with this kind of setup is that you can have, for instance, a full environment build out based upon app services, and you're using full paths. One of the nicer environments that Microsoft helped build was the Nobel Prize website that's still running in ASEs on Linux environments. And then they push back to a internal networking part where they can talk to blob storage, where they can talk to MySQL databases. They use the container registry to deploy from, and as you can see, they also use some CDNing, which is not being hosted on Azure, but they also make use of Azure Redis Scheduling. It works just the same as you have. Benefit here is that they, by use of the ASE, so the Azure Application Service App Service environment, sorry, is that it can be fully segregated from the outside world where it's fully unknown to the outside world, and that you can just hook into that by means of either private link or any other technologies that we have, and this being fully secured and managed in a very secure way. And we can just scale everything else like the standard app service scaling. So you have additional benefits there. Next on that part is the container instance. The container instance is just a very lightweight way of actually looking at it as a VM, but it's a pure container that we're running for you. What you do here, you set the amount of memory and the amount of CPUs, and you just deploy the container from either the registry or just from a build file, and you just push it from either the CLI or the portal. It's very easy to do, actually. And the beauty of it is that it can, you can just run it in a networked way if you want to make your life a little bit harder, or you have some different challenges and you don't want to use a fully Kubernetes approach. You can use them to combine them in a networking way. Do note that it comes with some challenges when it comes down to IP addressing and interacting between all, but there, we offer some tooling to provide that a little bit easier. But next to that, you can also use containers to scale out your Azure Kubernetes service as an additional virtual kubelet, so that way you can have more benefit of not pushing full nodes, but just pushing simple containers as an additional scaling inside of your Kubernetes environment. And also they're fully isolated from everything else. So if you don't explicitly combine all these things, they're fully isolated in a hypervisor way. So if you take a look at this, I can show you this. We have a container instance here. The same application that I did, I didn't pass on a CDN, so by default it gets an IP address, and you can just use that. I can just copy the IP address here, go to the browser, open up a new window, and this will, as you can see, it's the same application that I was pushed here. I used the same image, the same container image from that application. So what I did here was I deployed it from the container registry. The containers themselves which are running, you can monitor, you can do a little bit of monitoring there. You can look at the properties and the logging itself, what is running underneath, and a little bit like in the app services that you just saw. You can even connect to it, and then you can say, I want to use the bin bash, and then you can start looking at the properties itself. And normally I can, if I start typing, as you can see, these are all the entry points that are there. I can just say bin, and I can actually go fully inside of the container and look at all the things that are being run there, and where the application is being hosted, and so on and so on. You can immediately hook identity up to those. You can take a look at the activity log, just like in any other resources. You can have some metrics on these. Pretty cool, just looking at what the CPU and the memory is doing. And for maybe running your container first as an ACI, to take a look on how they perform to better help you look at your container deployment in the Kubernetes afterwards, to give you an idea how these are running from that perspective. So a lot of cool tools that we have here that you can use to your benefit. And it's very easy, as I said. You just go to the registry, you do you deploy it from that registry, and you can just switch any kind of image. If it is, of course, exposed outside of your containers, the application is, of course, exposed outside of the container, then you can just start that thing off. Service Fabric, as I mentioned, Service Fabric allows you to also run containers. I'm not going to go into depth too much about it. There is demand for Service Fabric, but we see more and more that people are either rewriting their applications in .NET Core and pushing them natively to Kubernetes services. But do note that the way you deploy your containers will not need to be modified. They just stay the same, and you just can run them there. Some of the benefits of Service Fabric, of course, is the health and monitoring part, which has a very nice touch to it, the way it heals and moves away your applications from one node to the other. And do note that we fully support this still from a container perspective also. Very cool if you want to run some Windows containers natively. This was your first call today to run Windows containers, as we said. And then comes the best known system to run containers in an orchestrated way, which is, of course, Azure Kubernetes service. We used to have two services. We used to have Azure Container Service also, but we pushed that away because we saw that Kubernetes was the way forward to move inside of container orchestration. We didn't see any industry interest into things like mesos and DCOS anymore, and also either Docker didn't put a lot of effort in there either. This is just a native Kubernetes. Today we have support for version 18. And we support also version some lower versions there, but we are trying to maintain speed together with all the other Kubernetes deployments that we see in the market. So if there's a Kubernetes release, we try to update that release also inside of the Azure Kubernetes services, so you can benefit from all the features that are being developed in there. That's the beauty of contributing to the open source of Kubernetes. The beauty of it all is that it has it can work with any open source tools that you have and APIs, but we provide some additional things like better pod security and better security for your Kubernetes environment. We can help you scale in different ways. As we mentioned, we gave back virtual kubelets back to the world, but we also have virtual node pools. We also have support for GPUs in those node pools. You can even scale to 0 now in your node pools, which is also very cool if you want to cost optimize a little bit. You can benefit from spot instances, for instance, to do your scaling. So that way your container, your Kubernetes environment doesn't have to be very costly, or doesn't have to be a full running cost of a full running VM. What you typically see is you will only use not fully your Kubernetes environment. You will have some idle time, just like with VMs, but it will give you breathing space for all your containers that you're deploying. What we typically suggest is either run some of your base nodes in burst methods, or run an additional node pool next to that if you're sure that you're going to reach 100% or a 99 or 95 percentile resource consumption. Run some virtual node pools next to those with spot instances, so that way they can you can benefit from quick compute if you need them. Do note that spot instances can be depleted anytime, hence why they are so cheap. So don't do this if you have a volatile production environment. So if it's something that needs to be long running and you're not sure that it can just be depleted, then don't use spot services. But if it's just something for a quick compute, then go ahead, perfectly possible to use. And also you just use some burstable VMs, or some make your nodes a little bit smaller in compute size and optimize to the compute usage. We offer some calculation methods on those two with some of our services that we offer, so we can always talk about this. If we take a look at the way we have that inside of the portal, I have deployed one Kubernetes cluster here. As you can see, just a standard API address, which you can use then to manage your environment. And if we then take a look at all the namespaces that have been deployed, as you can see, there's all the namespaces that you've deployed on the Kube node. We offer the management for free for Kubernetes, by the way, the management node, and everything else will be used for your own workloads. You have service and ingress support, as you can see here, so you can see the metrics, but also, like for instance, Kubernetes dashboard. You can sorry. You can go to these endpoints immediately from internally. You have a good overview of how these work and how these come by. You can take a look at the YAML on how these were deployed, and then you can reuse those. And of course, from the scalable way of doing it, you can easily scale your nodes itself. But as I mentioned, it's better to use a lower set of nodes inside of your standard node pool, and then do additional agent node pools next to those, and add node pools from there out. So that way you can easily just scale on demand if necessary. We offered support for deployment center also. You can have built-in CI/CD from that part. So we can set policies on these things, where you can have, which is an add-on that you need to enable. And from these policies, you can set security constraints. You can and you can make sure that all your Kubernetes clusters are being deployed in the same way, just like with any other policy that we have today in Azure. Also very key, what I'm very keen of is, if you're taking a look at a cost perspective, it's the implementation of Azure Advisor. And it's not only a cost perspective, but it's also on a security perspective that we're talking a little bit later, more on that in just a second. So what else do we have in the container estate? Well, something which is easily overlooked and easily let's not call it underestimated, but valued, is the Azure Batch. I typically see today when we talk to customers and partners that if they want to do something like machine learning, they typically always want to run inside of Kubernetes. But sometimes it's better to run a training model not in Kubernetes, but in something we call Batch, which will help you just run the entire training model, train the model in a very short burst way, and then put the result back as a trained model and push that one back. And you don't need to keep your environment fully, unless you're doing a lot of training, of course. But typically you don't need to keep that environment fully running. Yeah? So this is where Batch comes into play. Batch is based upon a couple of things. It's VM scale sets combined with a batch orchestrator, a batch job scheduler, and even a support from HPC, high performance computing. We typically see the usage of Batch in partners and in customers like Disney, because they're using this technology to render all the latest Pixar and Star Wars movies, for instance, all the latest LucasArts movies. So everything that you see nowadays since the usage of Solo, I think it was, those are being rendered fully by means of Azure Batch. So, and you will benefit greatly of this because your compute time will be a lot shorter. You will use a lot more devices in the background, but that doesn't mean that your price will go up extensively. Typically, you can. Sorry, that's what I heard. I was hearing noises, but it's because of my gardeners in the garden. Sorry about that. So typically you will use this technology to do a lot of computing next to each other and talk to, render, train the model, execute models, and so on in a very short way, in a very short-term way. So this is actually the best way of running these things. So think about if you're doing machine learning on container-based things, think about Batch if you just need to train your model and you don't need to keep your infrastructure up and running. The Batch scripting and the Batch tooling that we have is very useful and very intuitive, and it just works with the containers that you wrote. The only thing that you do need to keep in mind is that you want to fully benefit is that you make your model distributive, so that way it can benefit from the distributed computing when inside of Batch, of course. Okay, any questions on that? No questions. Goodie. And then the final part that we have is, of course, the Azure Container Registry, which is the basic for all the storage, as I mentioned before. It can manage the images for all your types of containers, but it will also do the building of your containers and the testing of your containers, and it can do an easy geo-replication of your container registries. We try to make the distance between your deployment platform and the container registry as small as possible. So we also try to optimize the speed for those things. This is typically something, if you're building a container, you always need to download a container and then you start building up your application within the container and then you push it again. We try to minimize this by using the Azure backbone to push everything through and optimize the speed for the container registries. Some of the things that you have in there in the container registry part is, as I mentioned, I'm going to show you, is that you can easily have the repository. In this case, that was my static site. The repository that you have, you can take a look at the containers, you can take a look on all the manifests and all the metadata. You can easily just say, I want to create a webhook out of here, so that way you can just start consuming it. But you can also create a deployment from here. I know right-click deploy isn't a friendly way of deploying applications, but from here, for instance, you can say I want to run an instance of my application, or I want to immediately deploy that to a web app. So you have a choice there too to manage that. You can easily also manage all your access keys from here out, because it will be seen a little bit as a standard, just like a Docker Hub way of approaching it. You can create an admin user for those and keep it in a safe way. This will be deleted afterwards. Don't worry about it, or it just will regenerate the keys. This is not a safe way of doing this. You can integrate with networking and just push in a virtual way, in a safe way inside of your network on the rest of your applications. And then you can also give repository permissions, and do also content trust of yours. It's willing to load. I think I broke it. I think I was building a little. Let's refresh this for a second. Yeah, that's way better. And as you can see, there's also container security integration. So we offer security integrations from the marketplace. We have the tasking here, the ACR task, which is build, run, push, and patch containers in ACR within the environment. So you can easily use those, and these can be easily done through means of the CLI or any of your applications that are using these specific things, or just upon push that the build will be triggered upon push, for instance. I mentioned before that there's a tight integration with all the technologies, also from a security center part. Maybe take a look at this too. Why I put some focus on this? Well, security is one of the monitoring things that we have at the end, typically of the line of a DevOps lifecycle. Please note that we try to invest, that we also trying to push a little bit more left. So it means developers have a higher impact on security than you might even imagine, or than most people imagine. So hence why we try to be more sentient and more aware of the impact that a developer can have on everything container related. So if we take a look at our container landscape, you can see here that in the underneath the computing apps part, in the resource security hygiene blade, there's actually a containers tab that you can open up. And here you can take a look on how secure your containers have been deployed, or how secure your Kubernetes instances are. For instance, here, this is my Kubernetes cluster that I'm running for another demo. And as you can see here, there's some high security impacts on here. And the recommendations here would be that, if it's willing to load, that, for instance, here in this case, only authorized IP range should be defined on the Kubernetes services, for instance, to minimize the attack surface. And also that I should be starting to implement role-based access control inside of the Kubernetes services and with the Kubernetes services. So these are all things that you can scan. There's a lot of rules for container-based services. This is specifically for Kubernetes, but if you take a look at the container registries itself, they also being scanned from a deployed mechanism. So every single time you deploy a container, this container will be scanned upon vulnerabilities inside of the container. So if you locate like a vulnerability of the OS, for instance, which hasn't been patched, it will be highlighted. If you find a vulnerability based upon a port that is being opened too much, that will be highlighted, and so on and so on. Now, for instance, here we have a audit diagnostic settings. This will just be a minimum one, but it you can immediately take then action on these things. It will help you make your sources already more safe. It will be checked every single time you have a push of a container, of a new version inside of the repository. So there's no excuse anymore, at least on that level, to minimize the attack surface and to take a look on how you're securely building your applications. Of course, next to that, you should also be scanning your builds and your containers itself upon the push from the source itself, which is a given. We also have the monitoring of our container instances. For that, we have a container insights, whether it's with Kubernetes insights or with container insights directly. As you can see, we can monitor everything ranging from the cluster. And as you can see, there's almost no load on my nodes. Going to the nodes, and nodes specifically, as you can see, everything is green. You can use these metrics. You can read these out. You can look at the live data if you want to. You can take a look at all the agents that are running, and then you can take a look at your application itself. All the usage that has been pushed in there. You can take a look at the health of your controllers, but most important, of course, is the health of your containers, where you have deployed your applications, as I mentioned before, right? And you can even monitor now some of the deployments, the way they are being deployed from this perspective. The same goes for anything else. So if you go into monitor, you can actually have container insights from here out. And this can then be combined with application insights. You are welcome. This can then be combined with the data from application insights, as you can see here, because this is just log analytics in the background that you can use, and then you can do correlations on the data that you have on both parts to see whether there is either an issue within your cluster or whether it's an issue in the application, or if they're coming hand in hand. And more insights will be given in the future. Okay. As I also mentioned, that it's not only Azure that is having an impact. We also have an impact by means of GitHub. GitHub is becoming more and more a part of Microsoft as you know it. We are a proud owner of the GitHub community. It's not only the hosting of the Kubernetes platform sources that we are doing there, we're also doing a lot of impact when we talk about CI/CD and the support for developing containers and container applications. And we recently announced GitHub container registries by means of GitHub packages. So if you take a look at the GitHub packages pages, you can implement that easily from there out. Another cool thing that you can also do with GitHub is the support for code spaces in this part. So I can just start editing my containers, and I don't need anything else anymore, but I just can start editing my containers environment and my sources from code spaces. It's loaded. Second. From the sources, as with anything else that you have here, and there's full support for the source codes. But as you can see, this is my source control for the application. The application here, as you can see, this is just a static file. Take a look at this in CodeSpace. It's the same structure. This is my full GitHub. It's running in a browser. You can easily just run it. I saw a cool demo last week on a Surface Duo, so those will be good tools to use the Surface Duo with. And then you can start using all the different extensions from there out. Talk to the registries. I can just connect to the registry here, and I can say I want to connect to Azure, and immediately once I'm signed into Azure, this will give me my sign-in credentials. I can now close this window. If I now take a look back at my environment, this will be signing me into all my subscriptions that I have access to. And then from here out, I can easily go to my container registry, which I have here. So this is my static one. As I showed you, and this here you can see the repository where I deployed those sources. I have too many extensions that I'm running here, and as you can see, an hour ago I pushed version 3 into that static container. So if I were to say now I want to do a full CI/CD from development part, I already set up a CI/CD release pipeline based upon Azure DevOps pipelines. I can just now say I'm just going to edit my my index file here. I'm just going to say here, clone your view your on Azure DevOps and GitHub Actions, for instance. I'm going to change that. I'm going to save this. Voila. And I'm just going to go with a push from here out. And as you can see, I'm just going to make sure that I'm going to do all the changes first. I'm going to stage all, and I'm going to make sure that I do a full full push sync. There we go. Yes. Origin master will tightly integrate with those things, and then the entire CI/CD pipeline will kick off. And as you can see here, all goes well. Should be. No, it's not there yet. This has been set up. It's running already. Beep, 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 beep. Am I connected to the wrong source? No, should be. Oh, it's the wrong one. My bad. Thought I did do the boom, boom, boom. No, it was a correct application. Why is that not? But it hasn't been pushed yet. All right, push. Something is wrong. Nah, that's why. I know bad message should be having better messages, but you get the idea. And if we then take a look here, you will actually see that this will be updated in just a second. Now it's uploading. That's what you get. If you forget to commit, that will be better. There you go. All right. So this is now being updated, and if now all is well, you will see a commit being run. As you can see, this will just run a standard build of my application, and it will build an image. This image will then be pushed back to my ACR, so my container registry. It was this one that I push an image. I think it's this one. Yeah, it's this one. So if I go and take a look here, you will then see this pushed. So the security center will be put into work. The version will be pushed, and then the release pipeline will be pushed, will be enabled too. Now, if you want to quickly set up a release pipeline for your GitHub code, you can easily do this by means of a DevOps project. I don't know if any of you know those, but pipelines is still a good way to run your CI/CD. You can easily set up a DevOps project, and the cool thing is that you have an additional benefit of setting up some nice visualization with everything that you need regarding to your application. I don't suggest you do that for everything, but this can be a good starter to create a build pipeline based upon your GitHub code, and then start moving away from your and then you can start moving away from your DevOps project and start integrating fully more in your either GitHub Actions or your pipelines, release pipelines. And it even has application insights built in as a standard dashboard part. You can immediately go to the endpoint from here out, so you can easily just take a look on how your build is being watched. As you can see, it just stopped building successfully and then now starts deploying. That works like a charm. But as I said, GitHub Actions is also a way of deploying it. Today, you can just start doing an action here. You can set up a simple workflow, but you can immediately deploy the application from here out. And as you can see, there's more integration parts as you want for deployable from any kind of technology. If I were to do this, I can just say, I'm going to set up this kind of a workflow to deploy Node.js, but it could be easily just a standard workflow. So if I were to do this one, it will generate me a YAML file, which then be pushed under my source control in the workflows folder, and then you can start building out your YAML file from that part. There's a you can give it a webpath name immediately. So all the things that are immediately supported by Azure, you can just build these out. If you do that, you can also choose some of the featured actions, and if you highlight those, they will be added inside of your YAML code. You can easily say web app, for instance. As you can see, there's a web app builder tool. If you say container, there's support for container registry logins and container deploy to container instances. So you can easily build these out with a high support from GitHub Actions too. Voila. That's about time. That's about time for this session. If there's any questions now, I will be happy to take them inside of the chat window. And if not, if you don't want to chat about those, I'll stop the recording here, and we can have a discussion by means of voice, if you prefer those. So any questions? So I see there's no questions. Well, then I just thank you for your, oh, sorry, apparently there's somebody still typing a question. Okay. Since that there are no more questions, I'm going to stop the recording, and I want to thank you again for your presence. Do stick around if you still want to ask questions by voice, and then we can take it from there. I hope to see you on any of the other partner journeys in the near future, for which you will probably get an invite. And there will be also Q&A hours organized in the next coming months and weeks. I thank you kindly for your presence and for your attention. Bye-bye.